This is a little help tutorial for the basic trig functions worksheet that I did for the flipped assignment. So some things you should remember from geometry is when you have a right triangle, the side that's across from it here is the hypotenuse. And both A and B, these sides coming right out of the right angle, these are called the legs. And depending upon where our angle is, we're going to reference different parts of it. So our sine, you should remember, is the opposite over the hypotenuse. And cosine is the adjacent leg over the hypotenuse, and then tangent is the opposite over adjacent. And so if we apply that over here to the sine of theta, so when I want to talk about the sine of theta, I want to talk about a particular angle, and the angle is theta. So that means I'm referencing this angle here, and everything is regarding that. So when I want to do sine, I want to do the sine of theta is opposite. Well, going across opposite, that's B. And the hypotenuse is C. If I want the cosine of theta, cosine is adjacent, so that's right here. So that would be A over C. And then the tangent would be opposite over adjacent, so B over A. So that's just a little refresher for that. If we go into the next page and we actually apply it to this here, we're going to be referencing the sine of alpha here. So I'm going to just use that angle. So if I want the sine of alpha, it's going to be opposite 5 over the hypotenuse, which is 13. If I want the cosine, I'm going to do the adjacent over the hypotenuse. And if I want the tangent, I'll do the opposite over adjacent. Let's do the same thing over here for this triangle. This one we're referencing beta here, this angle. So if I want the sine, well, that's opposite. So opposite, I'm going across. So 15 over the hypotenuse, 17. Cosine is adjacent, so we have 8 over 17. And for tangent, we have opposite, 15 over the adjacent. All right, going into finding a missing side, here's our missing side. It's x. So it's always good to see what angle we're given. We're given this angle here. So we need to figure out in regards to what we're given, which information we're given, what sort of trig function we'll need to use. So it looks like I have to deal with the hypotenuse. That's the one that's opposite this 90-degree angle. So the only two that deal with the hypotenuse are either sine or cosine. So I'm going to be using those. But for 28, well, let's see if I'm given the opposite. Nope, not given the opposite side. I'm given the adjacent side. So which of our trig functions deals with the hypotenuse and the adjacent? And that would be cosine. So we'll do cosine of 28 degrees. And that's going to be equal to the adjacent and the hypotenuse over the hypotenuse. A couple different ways people want to go ahead and solve these. You can just actually switch the places here because it's like a ratio over 1. But if you can't see that, what we're really going to do is cross multiply. So we'll have x times the cosine of 28 equals 22, and then we'll have to divide by the cosine of 28 degrees. Those will cancel. So x is equal to 22 divided by the cosine of 28 degrees. Now, like I said, you could have just switched the place with x and the cosine of 28. So if we bring up the calculator, here we go. Let's make sure that our document is in, it's not, so it's in radians right now. So when we're calculating these trig functions, we want to make sure that we are in degrees. And I'm going to make that my default right now. All right, so now that I know that I'm in degrees, I'm going to take 22. Let's open up a new document. There we go. All right, let's add a calculator so we make sure we have a clean page. So 22 divided by, and we're going to look for our trig functions, and they're right here in this button. And we're going to go to the cosine. So we'll go over 1, hit enter. Cosine, and we want 28, and we know we're in degrees. And then we'll hit enter. Ah, see, look what I got. I got something that gave me an exact answer again. So we'll hit Control Approximate, and it's going to give us the approximate value. So x is approximately 24.9, and this doesn't happen to have any units on it. So we're going to say about 24.9. That's the length of this side here. All right, let's go to the next page. Now we're going to find a missing angle. So here's our missing angle that we want. And again, let's look and see what sort of information we're given. Well, we know we're given the hypotenuse. And if we're given the hypotenuse, we're going to use either sine or cosine. And if we look at what we have, well, we have the hypotenuse and we have the opposite. So the opposite in the hypotenuse is sine. So we'll use sine of x equals, and we have the opposite over the adjacent. And now we're given a ratio here, and the variable that we're looking for is actually in sine right here. So we always have to perform an inverse when the variable's in a function here. So we're going to do that by taking the inverse sine of the value we have here. And that's going to give us x. So remember when we were doing inverses, we said that the inverse was when you had a superscript up here to a -1. So it's not sine to the -1, it's the inverse sine. And when you perform the inverse sine, this value comes in here, and we're actually just going to calculate that. So go into trig functions, and we want the inverse. These are all our inverse. So we want the inverse sine of 12 divided by 20. And we'll hit enter. And I'm going to get about 36.87. So let's write that here. So x is about 36.87 degrees. So when we're finding missing angles, we need to use the inverse operation. Now we're just given a problem to solve completely, and I need to come up with both this side here, and we're going to call this side little d. We tend to name all of the sides of the triangle in the lowercase version of the angle opposite it. So we're going to, let's see, what do you want to solve for first? Let's solve for, how about we solve for side D? So we see we're given the hypotenuse, and here's our angle. So if I have opposite and hypotenuse, I'll use sine. So the sine of 62 degrees is equal to D over 12. And in this case, since the variable is up in the numerator, all I need to do is multiply both sides by 12. So 12 times the sine of 62, so 12, the sine of 62. And D is approximately 10.6, we'll say. So this side is 10.6. And now we can find the value of R here. And we can find the value of R by either doing adjacent over hypotenuse. That would be probably the most accurate way, since we're not going to use an estimated version if we were to do something like tangent. Another way to do that is to come up with this angle here, because to completely solve the triangle, we need to know each piece. So if we're looking for angle R is going to be equal to, well, 180, that's a total triangle, minus 62, these are all in degrees, minus this one here, which is 90 degrees. So we can come up with the measure of angle R, and we can do that by just going over to the calculator. So 180 minus 62 minus 90, and that gives us 28 degrees, so 28 degrees. So we can also use this value to calculate if I wanted to do opposite over hypotenuse again, if I wanted to use sine again. But in this case, let's go back and use cosine. So the cosine of 62 degrees is equal to the adjacent over the hypotenuse. So our side R is equal to 12 times cosine of 62 degrees, and if we do that, 12 times the cosine of 62, and that's approximately 5.6. So here's our completely solved triangle. We know each side and each angle.